Hey guys, welcome to day 22 of 100 days of code. Today we're going to be building the famous Pong game, and you're going to be doing this by using all of the skills that you've learned up till now. Pong is a classic arcade game, probably one of the first arcade games there ever was, and it has a really simple premise. It's basically just a ball that's going across a table, and two players each control a paddle, bouncing the ball back and forth. If you miss the ball, then the other player scores a point. Now, the history of Pong is itself kind of fascinating. It was created and written by this guy, Alan Alcorn, and he was a fresh recruit to the Atari company. And in order to test his skills, they decided to get him to create a game from scratch. And this game happened to be Pong, which became a huge success, selling loads and loads of machines across bars and pubs in the world. It eventually became so successful that a lot of these bar owners were calling up Atari saying, "Hey, your machines are breaking after only a few days." And the reason when they investigated was because the machines were chock-a-block full of money. People were putting their quarters in to play Pong, and the machine was getting full too quickly. So this is the legendary game that we're going to be building today. As always, the first step is to break down the problem. And I want you to have a go at this. Think about how you would take this Pong game that you've seen here, and which components would we need to write code for? Which components might fit well in its own separate class? And how might we break down the logic of this game so that we can solve it piece by piece? Now, I want you to take a piece of paper, take a look at the game screen right here, and make a note of which components you think could be separated into their own classes. Briefly pause the video and jot down some notes on how you might structure the code for this game. Now, I've broken this tutorial down into 8 pieces. Keep your piece of paper to hand throughout today so that you can compare your structure to the sample solution. Pong is a much more complex game than Snake, so pausing to think about the structure of the code now will help you a lot more in the upcoming lessons, and it'll make it easier for you to see how everything fits together. First, we're going to figure out how to create the screen, how to create and move a paddle, and then create another paddle so we can have a 2-player game, and then create the ball and make it move constantly across the screen, and figure out when it collides with a wall and make it bounce back, and then detect when there's a collision with the paddle to know when to bounce it back. Finally, we'll figure out when a user scores when the paddle misses the ball, and we'll keep the score using a scoreboard like before. Now, if you're feeling really confident, you can, in fact, just create a blank project, go through these each steps one by one, and see if you can code up this game by yourself. But what I recommend though is to go along with the videos, and I'm going to explain each of the problems one by one, and you can have a go at building it alongside with me. So if you decide to follow along with me, head over to the next lesson and we'll get started. If you decide to create everything from scratch, then pause the video and start creating the game now. The first challenge is pretty simple. We're just going to create the starting screen. It's going to be a screen that has a height of 600 pixels and a width of 800 pixels. It should be black in terms of the background color, and it should stay on the screen until we click on it. So using what you've learned so far, go ahead and set up the starting code for our project. Alright, so I've created a brand new project, which I've called Pong Game, and I've created a main.py. Now, the first thing I'm going to do is I'm going to import a screen from the turtle module. And then I'm going to create a screen object from this screen class, and then I'm going to set the background color to black. And then, of course, we'll need to set up the screen so that it has a width of 800 and a height of 600. So now if I run this code as it is, you'll see that it flashes up and it disappears. So of course we need that exit on click method as well. As a final finishing touch, this is completely optional, but it helps to identify the program. We can change the screen's title to say Pong. And now when I run the code, you can see that this window now says Pong. So we now have our 800 by 600 screen, and we're now ready to head to the next step where we create our paddles. So now that we've created the screen, we're ready to go ahead and create and move a paddle. So the paddle that we're going to create is going to be on the right side. It's going to have a width of 200, a height of 100, and be positioned at 350 pixels on the x-axis and then 0 on the y-axis. So this is the sort of positioning we're looking for. And additionally, we should be able to hit the up and down keys on our keyboard to move the paddle. Each key press should move the paddle up or down by 20 pixels. Have a think about how you might create the code for this and pause the video and complete the challenge. Alright, so to create this paddle, it's going to be created as a turtle. So let's go ahead and create our paddle from the turtle class, and I'm going to set the paddle's shape to a square. In order to stretch it so that it's 20 by 100 pixels, remember that all turtles start off as 20 by 20. So that means in the width, we have to stretch it by 5, and in the length, we leave it as it is in order to make it 100 by 20. So let's go ahead and hit up paddle.shapesize, which is what we've been using so far. And then in terms of the stretch width, we're going to make that 5, and then the stretch length is going to be 1. Now we have to make sure that our paddle has a color of white so that it's actually visible when we run our code. And you can see there it is. There's our paddle. And as always, it gets initialized in the center at the coordinate 0, 0. So in order to move it to the position we want to, we have to get it to go ahead and pen up, and then we can tell it to go to the position that is 350 by 0. So 350 on the x-axis and 0 on the y-axis, like that. Now, the next thing we need to do is figure out how to get it to move up and down. So of course we need some sort of way of getting our screen to listen for keystrokes. We're going to call screen.listen, and then we're going to call onKey in order to listen for the up key. And then when that happens, we're going to get the paddle to go up. Now remember, as always, when you're using a function as a parameter, you don't want to add the parentheses. If you do, it won't work. Now let's create our go up function, and this function is going to take our paddle and move it so that it goes to a new position. The new X position is not going to change. The only one that's going to change is the Y position. So the Y position is going to be the paddle's current Y core, but it's going to go up, so it's going to need to plus, let's say, by 20. Now we can tell the paddle to go to its current paddle.x core, so we're not changing that, and then to go to the new Y position. Now this go up function is going to be called whenever the up key is detected, and if we copy this and we make a similar version of this function, which is called go down, and we can subtract 20 instead. So now we can copy this line and make it call go down when the down arrow key is detected. So now we've created our paddle, and when I hit up, it goes up. When I hit down, it goes down. And this completes the first part of the challenge. But here's a question. When I hit run, you can see that the paddle first gets created in the center, and then it moves to the location where it needs to go to, which is 350 on the x-axis, 0 on the y-axis. How can we get rid of this animation so that we don't have to look at the paddle move to the position? Have a think about what you've learned in previous lessons and see if you can solve this problem. Alright, so you might remember from previous lessons that there is a tracer method on the screen which controls the animation. And in order to turn off the animation, we can put a 0 in that method. But when we run our code as it is right now, you'll see that there's no animation, there's not even a paddle showing up anymore. Remember that when you turn off the animation, you have to manually update the screen and refresh it every single time. To do that, we'll need some sort of a while loop. And the while loop is going to check for some sort of variable. So let's create a variable called game is on and set it to true. And while the game is on, then we're going to call screen.update. Now, if I run the code again, you'll see that my paddle now goes directly from the center to the position, because the first thing that happens is the animation gets turned off, the paddle then gets created in the background, and then finally it gets to this point where we actually update the screen and show everything that's happened in the background so far. Did you manage to complete this challenge and create the paddle and get it to move up and down using the keystrokes? If not, be sure to review some of these methods in the Turtle documentation and have a play around with the code until you're fully happy with what's going on so far. Now, if you had created the paddle in a separate file as a separate class, don't worry, we're going to do that next. We're going to refactor this code so that it's fully compliant with object-oriented programming. But if you've already done it, then you're just one step ahead. And that is where we're heading to in the next lesson. In the last lesson, we created and managed to move a paddle up and down. Now in this lesson, we're going to figure out how we can create another paddle, but we don't want to repeat all the code that we've written so far, so we're probably going to need the help of a separate paddle class. So if you haven't already created your paddle inside a separate file and a separate class, then this is the time to refactor your code so that you can create another paddle object from the paddle class easily and effortlessly. Here's what we're aiming for. We're aiming to get rid of all of this paddle related code and move it into a separate paddle class. And then subsequently, we want to be able to create a right paddle simply by creating it from the paddle class. And then we can create a left paddle from the paddle class. Now, because the right paddle has a different coordinate from the left paddle, we'll need to pass in the position of the right and left paddle as a tuple. So we might say something like the x will be 350 and the y will be 0. And on the left paddle, the x will be minus 350 and the y will be 0. So have a think about how you can make this code work and refactor this code into a separate paddle class. And this paddle class should inherit from the turtle class. Overall, our program should work pretty much the same as before, the only difference being that we now have a left paddle which can move up and down with the W and S keys on the keyboard. Pause the video and try to complete this challenge. Alright, so the first thing we're going to need is a new file, which is going to be called paddle.py. And paddle.py is going to need the turtle class from the turtle module. So let's go ahead and import it. And then I'm going to create this paddle class. And of course, all classes start off with a capital letter. Now, this class is going to take all of this paddle creation code, and it's going to carry it out when we initialize a new paddle object. This paddle object, in order for it to be a turtle object, we're going to get it to inherit from the turtle class like this. And in order to get all of the abilities, the methods, and the attributes of the turtle class, we need to get the superclass to initialize itself. The next thing we're going to do is figure out how we can get our paddle to change its shape, change its color, and all of these other things. So we can get rid of this line entirely because our paddle class is now the same as a turtle class. And then for the rest of these, instead of writing paddle.shape or paddle.color, we're going to hit Command R or simply go to Edit, Find, and then Replace, and you can take a look at the shortcut on your computer of how to get hold of this replace screen. So what I want to replace is everything that is paddle dot here in my code, and I'm going to replace it with self dot. Because now we're inside the paddle class, which is effectively the same as a turtle class with some added extras. We can tap into our methods and our attributes by simply using the self keyword. Now, the very last thing we need to do in order to make this work is to go ahead and import our paddle from the paddle.py. And once we've imported it, we need to address this warning. Notice how it's highlighting this area and it's telling us that this is an unexpected argument because the paddle class doesn't actually take any inputs when it's initialized. It's just got the self here. But in fact, we do need a position being passed over. So this position is going to determine where the paddle is going to go to. Because remember, the left paddle is going to have a different coordinate from the right paddle. So now that we've fixed that, this is now completely valid code. And if we run our code as it is, you'll see our paddles being created and looking exactly the same way as before, but now we've got one extra paddle. Going down here with our go up and go down methods, ideally we would want them to live within our paddle class. So we want them to be methods inside this class. And remember that methods always have a first attribute as the self. Now, in addition, we have to again replace this paddle dot with self dot so that it's actually referring to the object that's created from this class to get its y coordinate or get its x coordinate. Now, coming back to our main.py, we'll have to modify this code a little bit because this go up and go down function is now gone, and instead we now have the right paddle dot go up and right paddle dot go down. So the right paddle is going to be controlled by the up and down keys, but the left paddle, we can get it to be controlled by some other keys. Now in our case, I'm going to choose the W key to go up and the S key to go down. So we're going to need another set of these screen.onKey method calls. But in this case, this is going to get the left paddle to go up and the left paddle to go down. And the go up is controlled by the W key and the go down is controlled by the S key. So now if we run our code, you can see that when I move W, it goes up. When I move S, it goes down, and up and down moves the right-sided paddle. So notice how now that we've refactored our paddle related code into a completely separate class, firstly, our main.py is now a lot simpler. It's clear of all of this paddle related code. And on top of that, if I wanted to create a third paddle, let's say I wanted to create a top paddle for some reason, then all I have to do is just call the paddle class and then pass in a tuple for the location of this paddle. So let's put it at, I don't know, 100 by 100. If I hit run, you can see there's a third random paddle, and I didn't have to write any of this extra code or any of the related methods. We can create as many of these paddles as we want because we've now got this paddle class. So with these examples, I hope you're getting the sense of how important classes are and just how important they are when it comes to the development of a more complex project like this Pong game. Now in the next lesson, we're going to continue building out our program and we're going to create our ball class and get the ball moving. Now that we've created both paddles, the next obvious step is to create the ball and get it to move. So this ball is going to be created as a separate ball class, and the ball object that we're going to create from it will have a width of 20, height of 20, and its X and Y position will start out at the center of the screen, so 0, 0. Now, when the screen refreshes, the ball is automatically going to move on the screen, and it's going to move up and also to the right. So its X and Y positions will change on every refresh of the screen. So this is going to be a little bit more challenging and will require a little bit of thinking from your part, but I want you to pause the video and give this problem a bit of thought and see how far you can get in trying to get the ball to move to the top right edge of the screen. Pause the video and give that a go. All right, so to start off this time, I'm going to create a ball.py file, and inside this ball.py is where we're going to create our ball object. So firstly, I'm going to import my turtle class, and then I'm going to create my ball class, which is going to inherit from the turtle class, and then I'm going to do all of the usual initialization. And now we're ready to create our ball class. This ball is going to firstly have a white color, and in addition it's going to have a shape that is going to be a circle. Now I know that in the original Pong game the table tennis ball is actually a square, so you can keep it a square if you want to be historically accurate, or you can change it to a circle like I have here to make it look more like a ping pong ball. Now, in addition, we're going to need to get it to pen up so that it doesn't end up drawing across the screen. And now all we need is to initialize our ball from the ball.py. And we're going to do that just below our paddles. So I'm going to create a new ball object from the ball class. And now if I hit run, you'll see our circular ball show up in the center of the screen. The next problem is, how do we get the ball to move towards the top right corner of the screen? So that's going to involve a change in the X coordinate as well as the Y coordinate. In our while loop here, where our screen is updating, we're going to call a method in the ball class, which is going to be called move. And this move method, which we'll define now, is going to be responsible for moving our ball. And the way that it's going to move is it's going to increase on the X and also increase on the Y. Let's create a new X coordinate, which is going to be the current self.xcore plus a arbitrary amount. So let's say increase by 10. And then the new Y is going to be the self.ycore increased by the same arbitrary amount. And then finally, we can get our ball to go to this new X and new Y. So now when we run our code, you can see that our ball immediately goes off the screen to the top right corner. If we want the ball to slow down a little bit, we can do one of two things. Either we can go into the move method and change this 10 here to say a 1. That way, every time our loop runs, our ball will only move 1 pixel. Alternatively, we can pause the loop for a short time during each iteration. Moving the ball a tiny amount does work, but I'm going to go with the second option and import our time module. Then I'm going to get our while loop to sleep for a little bit in between each of the updates. So I normally start off with just a 0.1 second sleep, and you can see now our ball moves at a more reasonable pace and we actually have a chance of catching it with one of the paddles. That's all there is to it. We've now created our new ball class, initialized a ball object, and we've got the ball to move on every refresh of the screen. Now we've done most of the easy parts, getting a paddle and a ball up and running on our screen. The next few parts are going to be a little bit more tricky. And the first thing we're going to tackle is how to detect collision when the ball hits the wall at the top and the bottom and getting the ball to bounce. Now, we only need to detect collision on the top and the bottom walls, because when the ball hits the right or the left edges of the program, it should actually be caught by one of the paddles. And if it isn't, then that means that player has missed the ball and it's a point to the other side. So we need to focus on how can we detect when the ball has collided with the top or bottom walls. When has its position gone past a certain point that it probably is going to collide with the wall? We've done something similar in Snake, but it's again time to revisit this topic. Now, on top of that, we have to figure out how do we get the ball to actually bounce? And what does bouncing actually mean in terms of changing the position of the ball? When the ball is constantly going up in the y value and going up in the x value in order to travel in this direction, what actually happens to the x and y values when it bounces? Which one gets reduced and which one stays constant? Have a think about those questions and play around with some of those numbers and see if you can complete this challenge by yourself. If you get stuck or if you just want to check the answer, then come back and I'll go through the solution with you. All right, so it's going to be inside our while loop where I'm going to be detecting the collision with the wall. And in order to detect the collision with the wall, essentially what I'm going to say is that if this screen is 600 by 800, when the ball is at a y position that is above 300, remember 300 is half of 600 and the y-axis goes from 0 to 300 and 0 to minus 300. So once the ball is past 300, then it's going to be way past the wall, right? So at that point, I can be pretty sure that it's going to hit the wall or it has already hit the wall. So that will be my criteria for detecting collision. So I can say if the ball dot y core is greater than 300, well, in that case, it's basically gone too far up and it's hit the top wall. Now, in addition, I can add a or statement to say if the ball.y core is less than minus 300, then that means it's gone too far down and it's hit the bottom wall. So in this case, it needs to bounce. So we need to figure out how to get our ball to bounce. And we're going to create a bounce method in our ball class in order to tell it how to do this. Firstly, we're going to need to figure out a new y, because the y coordinate needs to essentially reverse. So whereas previously our y coordinate was going up and up and up, increasing each time, when it hits the wall, it needs to reverse direction. So if it was increasing, it needs to decrease. If it was decreasing, it needs to increase. So basically, we need the opposite of what it currently is. To do that, the easiest way is to create an attribute, which I'm going to call X move, and another, which I'm going to call Y move. These are going to start out at 10, and every time we move our ball, we're going to say self.xcore plus self.x move and plus self.y move. This basically hasn't changed anything. It's just that every single time the ball moves, it's going to increase in the x coordinate by 10 pixels and also increase by 10 pixels in the y coordinate. Now, when we bounce, however, we need to change our y move so that it's the opposite in terms of direction of what it used to be. So if it used to be plus 10, we want it to be now minus 10. And if it used to be minus 10, we want it to be now plus 10. To do that, all we need to do is multiply it by minus 1. So that means if y move is currently equals to 10 and 10 is being added to the y coordinate, then this ball is moving upwards. But when we reverse the direction by multiplying it by minus 1, now that is now minus 10. So we're now adding minus 10 to the y coordinate, which is the same as subtracting 10. So this is some basic high school maths that's going to get our Pong program to start moving in the right direction. Now, back in the main.py, under these conditions, when the ball has hit the top or the bottom, we're going to get the ball to bounce. And now if I hit run, you should see that when the ball hits the top screen, it comes right back, exactly in the way that we wanted to. But the only thing that we might need to tweak is look at how far it's gone before it actually bounces. It's completely disappeared off the screen before it actually makes a bounce. So we can adjust these values accordingly. So I think it works best when we actually have it as 280. So remember that the width of the ball is 20 pixels. So if we're 20 pixels away from the wall, then that's pretty much where we need to bounce. So if I run this again, you can see that the ball hits close to the wall and then it comes right back. So this will take a little bit of thinking to get your head around it. The best way to really understand this is to print out the values of the new Y and also of the Y move, and also after you've modified the move in the bounce. Look at those numbers and you'll eventually be able to understand what's actually happening to the position of the ball. But effectively, all that we're doing is we're defining an amount that the ball is going to move by in the X and the Y axis. We're adding that amount to the X and Y coordinate in order to move the ball. And when the ball needs to bounce off the top and bottom walls, we reverse the Y move number so that we get it to subtract instead of add. And that moves it in the opposite direction. So we figured out how to detect collision with the top and bottom walls and make our ball bounce off the walls. The next thing we need to do is to detect when there's a collision with the paddle and make the ball bounce off the paddle. This is probably going to be the hardest part of this program yet, so I want to talk you through the logic. Now, how can we know when the ball has hit the paddle? Now, normally we use the distance method to check what is the distance between the ball and the paddle. And if it's less than a certain amount, then we can be relatively sure that they've made contact with each other. So the code that we normally use would be something like this. We get our ball and we check its distance from the paddle. Now remember that our ball has a width of 20 pixels and our paddle has a width of 20 pixels. Normally we would say, well, if that distance between the two of them is less than 20, well then they've probably made contact, right? But the problem occurs when the ball hits the paddle, not right in the center, but at the edge of the paddle, because this distance measures the center of the ball from the center of the paddle as the distance. So you can see that this distance is way bigger than 20, so it's not going to register as a collision. How can we solve this problem? Well, we could add on an additional condition. We could check, well, if the ball has gone past a certain point on the x-axis, if it's gone far enough over to the right, and it's within a 50 pixel distance of the paddle, then that also means it's made contact with the paddle. Inside our main.py, I'm going to add a comment to detect collision with right paddle. So let's experiment with some numbers here and see if we can get the ball to bounce off the paddle. In this case, we're going to check if the ball dot distance to the right paddle is less than 50 and the ball dot x coordinate is greater than 340. If the ball has hit the right paddle, let's print something to the console to test our code. Let's print made contact. So if we run this code and I manage to make contact with the ball, you can see that it says make contact in our console. So instead of just printing make contact, what we want the ball to do is to bounce. Now this bounce is a little bit different from the last bounce because the previous one was changing its y coordinate so that it moved in the opposite direction along the vertical. But in this case, we actually want it to move along the opposite direction in the horizontal because the paddle's here and the ball's coming this way. We want it to go back this way. So instead of just calling this bounce, I'm going to right click on it and then refactor and rename to bounce Y, because this is bouncing in the Y axis. Now, once we hit refactor, it'll change it here and it'll change it here. Now, on top of that, I'm going to define my bounce X. So bouncing in the X axis. And this is very similar. We're going to change the X move, so the amount that the ball moves each time when the move method is called. And I'm going to multiply it by -1. So reversing the X direction. And then when our collision is detected, we're going to get the ball to bounce in the X direction. So now if we run our code, you can see that even though this only works on the right paddle, when the ball hits the right paddle, it moves back and it bounces back towards the left. It changes the direction that it was moving in the X axis. So now let's add the collision for both paddles, because they both need to bounce in the X axis. And so we're going to tag onto this a OR statement. And we're going to say, or if the ball dot distance to the left paddle is also less than 50. And on top of that, the ball dot X coordinate is less than -340. So this basically checks to see if the ball has gone far enough to the left as to be past the paddle and it's within a distance of 50 pixels from the left paddle. So if we run the code right now, you can see that not only does our ball bounce when it hits the right. So now when we run the program again, you can see that not only does the ball bounce on the right paddle, it also bounces when it hits the left paddle. Now, there's a little bit more tweaking that we can do with the coordinates, because you can see that when the ball hits the paddle, it goes a little bit too far before it actually reverses direction. So we can change this to a slightly smaller number if we want it to bounce before it's within the actual paddle. So we can change this to 320 and this one also to 320. And notice what happens now. Before it hits the actual paddle, it now actually bounces. And it doesn't look like as if the ball's fallen into the paddle before it turns back. And there you have it. Now we just have to figure out what should happen when the paddle misses the ball. For all of that and more, I'll see you in the next lesson. Now we're pretty close to the end of the program. We've managed to do pretty much everything other than detect when the paddle actually misses a ball. And if the right paddle misses the ball, then the left player gets a point. And this should trigger a restart of the game where the ball goes back to the center and starts off in the opposite direction. In order to do this, to detect when a paddle has actually missed the ball, effectively what we're checking is that the ball has gone past a certain point on the screen. So we know that we're already checking when the ball goes past this line and it's within 50 pixels of the paddle, then it should bounce back because that means the ball was caught by the paddle. But if it goes further than that, if it goes beyond that on the screen, like over here or over here, then that means it's a miss and we should reset the ball. Have a think about how you might create this behavior and as a challenge yourself, see if you can complete the code. So I'm going to add another comment here, which is going to be detect when right paddle misses. The right paddle has basically missed the ball if the ball.x coordinate is beyond 380. We know that the width of the screen is 800 and we know that the paddle is at 350. So the paddle basically goes from 340 to 360, and if it's already gone past 380, then the paddle has definitely missed the ball. So in this situation, we're going to get the ball to reset its position. And this is going to be a method in the ball class. So let's create it, and I'm just going to paste it in so I don't make any errors in terms of the naming. Resetting the position of the ball is going to involve getting the ball to go to the original position. So we can tell self to go to 0, 0. Now, if we run our code, you can see when the ball has gone past a certain point and it's not caught by the paddle, it goes back into the center. But we want the ball to go in the opposite direction once it's been missed by the right-sided player. It's time for the left-sided player to get a turn. So in addition to getting the ball to reset its position, we're going to get the ball to reverse its x-axis. So we're going to call self.bouncex. Now notice how when the ball gets missed, then its direction gets reversed. It starts off in the center and it goes off in the opposite direction. Let's go ahead and define the left-sided paddle miss. And we can do that by simply saying ball.xcore is less than minus 380. And in this case, we're again going to get the ball to reset the position. Now, the reason why I've got these in separate if statements is because later on we're going to need to detect when the right-sided player or the left-sided player actually gains a point. So when the right paddle misses, the left player gets a point. When the left paddle misses, the right player gets a point. Now, when the ball goes past the right edge and it's not caught by the paddle, then it starts off in the center and it moves to the left. When it's not caught by the left-sided paddle, it starts off in the center and it goes to the right. All that's left to do is to figure out how to do the scoring. And that is what we're going to do on the next lesson. To start, we're going to need to create a new scoreboard file. And then inside this file, we're going to add our usual imports and we're going to create the scoreboard class. Now the scoreboard class is going to inherit from the turtle class, so we can go ahead and add all of our inits and our super.init. Now let's define our scoreboard. It's going to have a white color, so it shows up on the black background. It's going to have pen up because we don't want it to draw, and it's also going to have its turtle hidden, because we're only interested in it being able to write something. And the thing that we want it to write is the current score. Let's go ahead and create some attributes for this scoreboard class. One is going to be the L score, which starts off at 0, and the other is going to be the R score, which starts off at 0. So our scoreboard is going to keep track of how the left player and the right player are doing. And then it's going to write this onto the screen. So we're going to write the self.l score first, and we're going to change the alignment to center and also change the font to something quite large, like a courier font with 80 points and have a normal weight. Where do we want this to be written though? Because by default, this is going to be written at the center of the screen, 0, 0. But instead, what we want it to do is we probably want it to go to somewhere on the top left of the screen. This is the left player score. So you can have a play around with the coordinates, but I found that minus 100 in the x-axis, so a little bit to the left of the center, and then 200 on the y-axis, so near the top of the screen, seems to do well for this left-sided score. Now let's make this show up by going back to our main.py and importing our scoreboard class and creating a new scoreboard object. So when we hit run, you can see that big 0 show up right here. Now, the next thing we need to do is to show the right-sided player's score. We're going to make our scoreboard go to the opposite side of the screen. So that's going to be positive 100, and again with a y value of 200. And then we're going to get it to write the right-sided score, so our score, and we're going to have the same alignment and the same font. Now you can see 0-0 when the game starts out. Now, what we actually want our scoreboard to do is to keep track of the score. So when the right paddle misses, it's a score to the left-sided player. We can define that in our main.py. When the right paddle misses, then we're going to get the scoreboard to give the left side a point. So maybe we could have a method called lPoint in our scoreboard that increases the point in the left-sided player. So we can say self.lscore plus equals 1. In addition, we're going to need to update our scoreboard, but all of that code is stuck in the init. So let's go ahead and move it out into a separate function, which we'll call update scoreboard. And we can call self.update scoreboard when we first initialize the scoreboard, but also when we score a point. Now, when we run our code, you can see that when the right-sided misses, our left side gets a point. But at the moment, it's overwriting the previous score. So to prevent that, we have to add a self.clear before we update the scoreboard. And you can see now it erases everything that used to be there and it updates the score. So we've addressed when our right paddle misses, but what about when our left paddle misses? Well, we should have a method called rPoint as well that gives the right side a point. So let's add that over here. So we'll increase the R score by 1. And we'll again call update scoreboard. Now, when our left side misses, we get a point to the left, and when our left side misses, we get a point to the right. That's pretty much all of Pong. Now, if you want an extra challenge, both in terms of playing Pong as well as the code, see if you can figure out a way of getting the ball to increase its speed every time it hits a paddle, because that will make the game a lot more exciting instead of having it always move so slowly. If you can't figure it out, then continue watching and I'll show you the solution. So in order to speed up the ball, the key is in how much time we make our game loop sleep. Because the shorter that this sleep is, let's say instead of 0.1 second, let's do 0.01 second. And if we run now, you can see our ball moves a lot faster. Let's make it even more extreme and add another 0. So how can we reduce this number by a little bit each time, but never make it go into the negative? Because if this becomes a negative number, then we actually get an error over here telling us that the sleep length must be non-negative. In order to do this, we have to figure out a way of making this number a little bit smaller each time. So let's make this number an attribute in our ball class. Now, I don't want to call it speed because that might be a bit confusing because the turtle class already has a method called speed, as you can see here. So instead, I'm going to call it move speed and I'm going to set it to 0.1. So now inside our main.py, instead of having a hard-coded number, I'm going to get hold of my ball.moveSpeed. Now, every single time our ball bounces in the x-axis, it means that it has been touched by a paddle. So inside this method, in addition to getting it to reverse its direction, we can get the move speed to reduce by multiplying it by a decimal number. So I've stuck with 0.9 because that seems to work for me. So for example, if we start out with a value of 5, and we multiply that by 0.9, it becomes 4.5. And if we multiply that by 0.9, it becomes 4.05. So basically, each time the ball bounces on a paddle, it's going to increase in speed. But this can't go on indefinitely. When we reset the game, once one player has lost, we have to set this move speed back to the original 0.1, just so that it doesn't keep on increasing in speed indefinitely. So now you can see whenever the ball hits a paddle, it will increase its speed ever so slightly, making it just a little bit more challenging for the players. Now, you can of course tweak around with that number. So instead of 0.9, you could have 0.5, which basically halves the speed each time. But have a play around with that and see what you prefer. Now, one last thing to mention before we finish off today is that when I'm testing this program on my computer, it seems like when I hold down the up key or the down key, my paddle will continuously move. But there seems to be a bug with Turtle where if I hold down the W key, it can only move one bit at a time. But it doesn't seem to affect the S key. So I've been doing a bit of digging around online and I can't figure out exactly why this is. If you manage to figure it out, then feel free to add it to the Q&A so that other students can learn from it. But so far, I've been coming up empty. But this is just a warning in case you find this behavior as well on your computer and you get confused and thinking it's something wrong with your code. It's not. It's something about the Turtle module that causes it to behave like this. So don't worry if that's happening to you. And if you're playing Pong with a friend, you can always trick them to use the left-sided player. Well done for completing day 22. Now today, I want to speak to all of your fears because I have a lot of them and I have voices which tell me you can do it, but also ones that tell me you can't. So one of the things that hold us back the most from growing, from becoming who we want to be, is fear. And when you're not aware of what you're scared of, it can often limit you and prevent you from achieving the things that you really, really want. Remember that fear is the mind killer. Fear is the little death. Fear is something that we all have to deal with. Nobody is brave. Nobody just doesn't feel it, but we feel it and we do it anyways. So think about what it is that you're scared of. What is it that you're scared of not being able to achieve? Are you afraid that, you'll never become a programmer? Maybe you're afraid that, you won't understand what's actually happening. Maybe you're afraid that you're just not good enough. We all have these doubts. And it's important to keep them in check. Think about what you're doing and think about what's the worst thing that could happen if I just gave it my all. Probably not very much. And you'll be surprised at all the great things that happen when you start looking at what you're scared of and just putting them aside for a moment and continue giving whatever it is you want to do all of your energy.